Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, An Academy. An Academy is the India's largest online learning platform. Now we are happy to announce that An Academy is going to providing online training for GATE and ESE Engineering Service Exams online with India's top educators. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. Okay, at present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. Now, first we check how to get an Academy learning app into your device. Just go to Play Store, type An Academy. Go to Play Store, type An Academy, and by typing An Academy in that, you will get the An Academy learning app like this. Just by clicking on this install button, it will install the An Academy learning app into your device. Now, what you will get? So by joining this An Academy, what you will get? First and foremost thing is daily live classes. Every day you have a live class. Second one is structured courses. Next, live tests and quizzes. Next, unlimited access. Now we check one by one in detail. Daily live class. See, every day you have a live class. The intention behind to conduct a live class on every day is always to keep the student in touch with the subject. With that intention, we are conducting live class on every day. Next, okay, during that live class, you can chat with your educator and engage in discussions. You can ask doubts and you can answer the polls. Once class is going on, you can do all these things. All these things you can do while class is going on. That is about daily live classes. Next, structured courses. See, whatever the course here you are taking, not only your course, every course which is available in an academy, it is going to be structured in line with your exam syllabus. That means updated syllabus. Everything is updated. Then it is very easy to the student to continue their preparation. It is very easy to the students to continue their preparation. Okay, that is structured courses. Okay, next, live tests and quizzes. See, you can evaluate your preparation with our regular mock tests and quizzes, and you can get the detailed analysis on your performance. See, once you completed your preparation, you need to evaluate it. That means up to how much level you completed, up to what extent you completed it. You need to evaluate it. So we can do that evaluation. You can evaluate it. You can evaluate your preparation by writing our regular mock tests and quizzes. Regularly we are conducting mock tests and quizzes. By attending those, you can evaluate your preparation. And one more, after that you get the detailed analysis on your performance. From that you can identify the gaps in your preparation. To fulfill those gaps, what you need to do, you can work out on that. Okay, that is about live tests and quizzes. Next, unlimited access. Unlimited access. See, once you take in a subscription, you can get access to all our live and recorded courses. Once you've taken a subscription, you can get access to all our live classes as well as recorded courses. Okay, and you can watch it from any of comfortable of any of your device. Either you can use a laptop, desktop, mobile, tab, whatever it is. Whatever the device you are feeling comfort, you can use that device. Clear? So these are the things you get by taking the Unacademy subscription. There are two subscriptions. Now we are introducing newly, that is a Iconic subscription. Iconic subscription is the next level of the subscription. In Iconic subscription, we take your GATE and ESE preparation to next level with personal coach. And before going to that, we go for Plus subscription. Plus subscription is the basic subscription. Plus subscription is the basic subscription. Okay, in this basic subscription, you get these things. Daily live classes. What are the things? Just before we discuss. Structured courses. Live tests and quizzes. Live tests and quizzes. Unlimited access. Unlimited access. So you get all these things while class is going on. You get all these things while class is going on. Now, in Iconic subscription, first of all, you get what are the benefits got by the Plus subscriber. You get all these benefits. First, you get what are the benefits got by the Plus subscriber. You get all these benefits. In addition to this, you get personal coach, study tracker, mains question and answer practice. Personal coach, what it is? See, here you get a one-on-one guidance from top exam expert. The top exam expert is acting as your personal coach. Top exam experts are going to analyze your exams. That means what are the exam you attempted or what are the quiz you attempted. They will analyze the way how you answer the question and your performance in that exam. Based on your performance in that exam, they will prepare proper study plan to you that is suitable to only you, and respect to study material also they will provide. By following all these properly, you get definitely success in their exams. Next, study tracker. Study tracker. See this here. You can evaluate your progress in bi-weekly reviews with your personal coach here. So you can evaluate your progress in bi-weekly reviews with your personal coach. For this, you need to participate in study tracker plan and study booster workshops. By participating in that, you can evaluate your progress in bi-weekly reviews with your personal coach. And most important thing is mains question and answer practice. In engineering service, you need to write one mains paper. Now you can strengthen your mains answer writing through regular practice. And whatever the exam you are writing during practice, what are the questions you are answering, we evaluate those questions and we give the personalized feedback to you. Okay, we evaluate those questions and we give personalized feedback to you. Okay, sir. So that is about your mains question and answer practice. So these are the things you get in Iconic subscription. And we take your GATE and ESE preparation to the next level with your personal coach. Okay, with personal coach. Next one. Yeah, now, so navigate. See, navigate your gateway to crack the gate. Navigate the way, gateway to crack the gate. This is for mechanical engineering, civil engineering students, computer science and IT department, and electrical students. Finally, for electronics and communication engineering students. Now you take the test and win the scholarship of what, 5 crores. You believe it or not, 5 crores worth of scholarship on the month of May 23 at 11 a.m. Don't forget to use my code VROUT10 during subscription. Okay. Now, see, in the month of May, every Sunday we are going to conducting combat, an academy combat. Okay, in that, if you get the rank 1 to 3, you get the complimentary an academy plus subscription for 1 year. And for rank 4 to 10, you get 75% off on an academy plus subscription for the tenure of your choice. 75% off if you get rank 4 to 10. If your rank is 11 to 50, you get 50% off on an academy plus subscription for the tenure of your choice. And for rank 51 to 100, you get 25% off on an academy plus subscription for the tenure of your choice. Here the tenure is either 6 months, 12 months, 18 months and 24 months. These are the different tenures. Okay. Now, first of all, what is this unacademy combat? See, it is the India's largest online scholarship test, weekly competition. It is India's largest weekly competition for GATE, and you can assess your GATE preparation within 60 minutes. And we are challenging that original GATE questions you get in this exam, which was curated by our best educators, and take it live to compete with the best, and super fast and fun with All India Live Leaderboard. See here, compared to the topper where you are, you can get that, and at the same time, based on your fast and accuracy of answering a question, your All India Live ranking is changing. And after that completion of the test, we provide a detailed video solutions to you. We provide. Okay, provide a detailed video solutions to you. Now here, through that video solutions, you can identify the questions which you are not solved in that exam, and you can get the information, complete information about the topic, about the concept. Okay, like that you can enhance your skills. Okay, enhance your knowledge. Okay, and the next combat is on May 16th. Already May 9th is over. May 16th and May 23rd, May 30th also is there. Your combat starts at 11 a.m. Exam starts at 11 a.m. And don't forget to use my code VROUT10. And these are the eligible departments: mechanical engineering, civil engineering, electrical engineering, electronics and communication engineering, computer science and IT departments. These are the eligible departments. Now, just we go to enrollment guide. That means to get the scholarship test, what is the procedure you need to follow? First, enroll for free from Android. So first register or enroll in your Android mobile, from your Android mobile. After that, appear the live for test. Write the test by live, and after that we provide a detailed video solutions to you. Just watch that and follow that video solutions. Every week do that, and by practicing 3 to 4 weeks like that, definitely at 1 week you win the scholarship. At 1 week. We give that assurance. Okay. Even if you take nearly 3 to 4 weeks, you practice 4 into 20, 80 different models you get. By following that 80 different models, definitely you get the scholarship in the next 5th week. Now, see, this is really a golden opportunity to the students who are going to writing the GATE exam seriously. 10,000 questions, 10K practice questions for GATE. 10K practice questions for GATE, which was curated by the top educators at an academy. Here, It is a master blaster practice series is going on. In that, a free special class series is going to be conducting. Okay, now in that 10,000 practice questions for GATE examination. These are the eligible departments for this: computer science, electrical engineering, electronics and communication engineering, mechanical engineering, civil engineering and chemical engineering. Okay, don't forget, use my code VIRAO10 to join in this master blaster practice series. Now, recently we started a new batches for GATE 2023 and 2022. There is a Ascend batch for GATE 2023 for electronics and communication engineering. This is for ECE department. Here are the top educators who are handling the subjects in this department. And don't forget to use my code VIRAO10 during subscription to get 10% discount. And this batch was started from 12th May 2021. 12th May 2021. Next, there is a Ascend batch for GATE 2023. Same. And this is for electrical engineering. This batch was started from 12th May itself. And don't forget to use my code VIRAO10 during subscription. And here are this is for electrical people. And this is the team who are going to handling the subjects in this. Next, there is a Evolve batch for GATE 2022 for electronics and communication engineering. Previous one is a GATE 2023. Now this is for GATE 2022. And this batch was also started from 12th May 2021. And don't forget to use my code VIRAO10 during subscription to get 10% discount. And here for electrical students, there is a new batches going on for these are the booster batches. This is the team of faculty who are handling the subjects. Okay, and this is going to be starting from 19th May 2021. And there is a booster batch for RSEB and booster batch for UPR VUNL and state AE exams. Okay, don't forget to use my code VIRAO10 during subscription to get 10% discount. Okay, now CMOS amplifiers problems. Now we are going to solving the problems on CMOS amplifiers problems on CMOS amplifiers. So just this is the first problem. Before for designing an amplifier, first you need properly biased MOSFET. Okay, first 2 to 3 problems are related to the biasing. After that we are moving to the topic amplifiers. Okay, first check this, just a minute, check the problem. Now see this, determine the bias current of M1 in below figure. Bias current means drain current, IED. Assume VTH 0.5, mu n COX 100 micrograms per volt square, W by L ratio 2 by 0.18 and lambda 0. Lambda 0 means omit the channel length modulation. What is the maximum allowable value of RD for M1 remain in saturation? So to operate this MOSFET M1 in saturation, what is the condition allowable value of RD? Okay, so first I am going to writing the equation for ID. So they are saying this is in saturation. Now in saturation, ID is equal to mu n into COX into W by L by 2 into VGS minus VTH whole square. VGS minus VTH whole square. That is the equation for ID. Okay, ID value. Now mu n COX they given W by L given, VTH given, VGS we need to calculate. For that I am going to taking the equivalent circuit of this. Whatever the input side circuit we have, I am going to replacing this input side by its Thevenin's equivalent. Okay, so for that first I am taking the output side, I am taking as usual. Output side circuit I am taking as usual. So this is the output side circuit. Plus VDD, its value is 1.8 volts. So input can be replaced by its equivalent Thevenin's. We don't want this value RG because RG is a 4K parallel with 8K, 10K. Because of this IG0, we don't want this, because even though you calculated that drop across, that is 0. Okay, that's why IG equal to 0. And we need this value. Now this value is VGG. Now I am getting VGG, it is nothing but a voltage across this. And the value of VGG is VDD 1.8 into simply voltage division into 10K by 10K plus 4K. So it is 18K, 18 by 14. 18 by 14. Now get the value. by 14, 1.28 volts. So this is 1.28 volts. So once it is 1.28 volts, current is 0. Now the voltage at gate, from this voltage at gate is 1.28 volts, and this is the drain current ID. Same drain current is flowing through this. This is the voltage at source, which is ID into RS. So RS is 1 kilo ohm, that means 1000 into ID. That is the VS value. Now VGS is voltage at gate minus voltage at source. So voltage at gate is 1.28 volts minus voltage at source is 1000 ID. Okay. Now take this VGS value, substitute in this equation. Now, so your ID is mu n COX by 2 into W by L into VGS minus VTH whole square. Substitute the value. Mu n COX 100 micro 10 power minus 6 amps per volt square. So W by L is, I think so, it is 2 by 0.18. VGS value just before we calculated 1.28, I think so. Okay, 1.28 minus 1000 ID minus VTH, they given us 0.5 whole square. Okay. So just check the W by L value. So W by L 2 by 0.18. Okay, very good. 2 by 0.18. Fine. This is your ID. So this is this. From this you get the ID square. It is a second order equation. Second order equation. Okay. Now just simplify this. 2 gets cancelled. 10 power minus 4. So it is so 1800 ID. 1800 ID equal to 1.28 minus 0.5, it is 0.78 minus 1000 ID whole square. Now just expand it. 1800 ID equal to 0.78 whole square, 0.6084 plus 10 power 6 ID square minus 2000 into 0.78. That is 1560. 1560 ID. Now we can write it as 10 power 6 ID square minus 1560 plus 1800. 3360 ID plus 0.60. Okay, 60 you can take approximate value, no problem, equal to 0.6. That is the equation for ID. Now I want ID value. So ID can be written as minus B, minus into minus plus 3360 plus or minus square root of B square. It is 1128 9600. B square minus 4AC 4 into 10 power 6 into C 0.6 by 2A, 2 into 10 power 6. Now I am going to taking the required ID. You get two values because it is plus once and after that minus, but we need minimum value of these two, that is our ID. Now directly I am taking minimum value means subtraction. So ID is 3360 minus, now simplify that, that is 2.4 into 10 power 6, 0.4 10 power 6, that is a 11289600 minus 2450. That is square root of that 298 1.5, 298 1.5 divided by 2 into 10 power 6, so which is minus 3360 divided by 2, it is 189 microamperes approximately it is 198 microamperes. That is the ID value. So far we calculated the ID value calculated. Next, what is the allowable value of RD for which for M1 to remain in saturation? for M1 remain in saturation. See, to maintain M1 in saturation, M1 in saturation, you need to maintain VDS should be greater than or equal to VGS minus VTH. That is the data you need to maintain. Okay, or so this value VDS, already we know that. Or you can write this one in another way. Okay, now, so this is our equation. VDS greater than or equal to VGS minus VTH. In this, you get VD minus VS greater than or equal to VG minus VS minus VTH. So I am reducing the complexity here itself. Both will cancel. Now this is the condition you need to check. VD should be greater than or equal to VG minus VTH. And this is the circuit they given at output side. It is 1K. Here is RD, VDD 1.8 volts. Already just before we calculated the ID. And this is going to be the voltage at drain VD. Okay, now we can write VD is VDD minus IDRD. IDRD, that's it. So VDD is 1.28 minus ID into RD. So it is 1.28 minus, sorry, it is 1.8. 1.8 minus, so it is 1.8 because VDD is 1.8 and voltage at gate is 1.28. So it is 1.28 minus 0.7. So this is ID. Previous just you calculated ID 189 micro. 189 micro. 189 into 10 power minus 6 into RD. So this is 1.8 minus 0.189 milli into RD greater than or equal to, it is 0.78. Take this portion this side, this portion this side. Therefore, RD is less than or equal to 1.8 minus 0.78 by 0.189 milli. Now just get the value of it. 1.8 minus 0.78 divided by 0.189, that is 5.39. So take approximate 5.4 kilo ohms. So this is the RD value should be less than this. Therefore RD is less than or equal to 5.4 kilo ohms. So maximum value of RD is 5.4 kilo ohms. If it is more than that, your transistor will come out of the saturation region. That is the limitation on RD value. Okay, so this is the procedure you need to follow. Okay, Next problem. See, this is also the same circuit. This is also the same one. In the following circuit, assume M1 is in saturation, fine, M1 is in saturation, okay, and RD is 2 kilo ohms, okay, RD is 2 kilo ohms, fine, and compute A option, first bit, the maximum allowable value of W by L. What is the value of W by L? And M1 is in saturation, no doubt at all, and RD value is 2 kilo ohms. Okay, and next bit is the minimum allowable value of RS with W by L 5 by 0.18 and assume lambda 0. Okay, see, first I am going to, it is in saturation. Now I am writing the equation for saturation. First it is mu n COX by 2 into W by L into VGS minus VTH whole square. And clearly they given it as in saturation. Okay, now in saturation we know one thing, VD is equal to, that means VDS is equal to VGS minus VTH, and it can also written as VD equal to VG minus VTH. Okay, voltage at drain is nothing but a VDD minus IDRD. So it is a VDD minus IDRD equal to voltage at gate, we got it already, 1.28 we got, minus 0.5. Okay, and from this you get VD value. This is nothing but our VD, 0.78 volts. That is the equation for VD. Now VDD, from this VDD is so this is our equation now, VDD minus IDRD is 0.78 volts. Now from this we get the ID is VDD minus 0.78 by RD. They given the values, VDD 1.8 minus 0.78 divided by RD, they given 2 kilo ohms. Now it is now it is 1.8 minus 0.78 divided by 2k, 0.51 milliamps, 0.51 milliamps. Okay, that is the equation for ID. So far we calculated the ID. Now check that the maximum allowable value of W by L. Now whatever the ID you get, take that ID, substitute in this equation, you get the value of that. Okay, so option A bit. So this is our equation for ID is mu n COX by 2 into W by L into VGS minus VTH whole square. ID you got 5.51 milli, 0.51 milli equal to mu n COX 100 micro by 2 into W by L into VGS, voltage at gate is 1.28 minus voltage at source is ID into RS value they given, RS is okay, ID RS minus 0.5 whole square. Now this is a 0.51 is equal to 10 power minus 4, 0.1, it is 1 by 20. So 1 by 20 into W by L, 1.28 minus 0.5, 0.78, minus ID is 0.51 milli into RS 1K. So now it is 0.51 into 20 is 10.2, 10.2 equal to W by L into, it is both will get cancelled, it is 0.1, 0.78 minus 0.51 is equal to 0.27 whole square, that is 0.0729. From this, W by L is 10.2 by 0.0729. 0.0729, that is 139.9. That is the value of W by L. So this is the limitation. Maximum allowable value of W by L is approximately 140. Okay, approximately 140. Clear? Now, 10.2 divided by 0.0729. 9. Okay, next part. There is a B bit in that. B part. The minimum allowable value of RS. Minimum allowable value of RS with the W by L 5 by 0.18. Okay, see. They given with the W by L 5 by 0.18. In this circuit, RS it is voltage at source. We know that this is our drain current. Already we calculated. Okay. And this is the voltage at gate. So we know the value of this voltage at gate 1.28. 28 volts. Now ID value, already we got that ID value, that is 0.51, I think so. Yeah, 0.51 milliamperes. 0.51 milliamperes. Okay. Now we need to get the value from this. VGS is voltage at gate minus voltage at source. So voltage at gate is 1.28 minus voltage at source is ID into RS. That is VGS. Okay. And from this we can write RS is V 1.28 minus VGS by ID. Just take the value of VGS, substitute here. Now how to get the VGS? We have a relation for VGS. So this is our equation for ID is mu n COX by 2 into W by L into VGS minus VTH whole square. From that, take this total part this side and square root of it, take this VTH this side. Then we get VGS is VTH plus square root of ID by 2ID by mu n COX into W by L. Just substitute the data. 0.5 VTH plus square root of 2 into 0.51 milli by mu n COX 100 micro into W by L 5 by 0.18. This one 10 power minus 4, this milli gets cancelled, this is 5.1. 5.1 into 2, it is 10.2. Okay, now it is 0.5 plus square root of 10.2 into 0.18 by 5. Square root, that is 0.605 plus 0.605. Okay, that is a 1.10 volts. Now RS is 1.28 minus 1.1 by ID 0.51 milli. So this is a 0.18 divided by 0.51 milli. That is 0.352 kilo ohms. So therefore RS is 0.352 kilo ohms. That is the value of RS. Okay. So this is the way to solve the problems. Okay. So next problem is calculate the drain current M1 in the following figure. If VTH 0.5 mu n COX 100 microamps per volt square, W by L is 5 by 0.18 and lambda 0. What value of RD is necessary to reduce ID by a factor of 2? Okay, next we check that. First calculate the drain current. And one more thing, first of all, this is the gate current, Ig equal to 0. Once Ig 0, this is the voltage at drain and this is the voltage at gate. Both are shorted. Both are shorted. Both are shorted. Okay. So once both are shorted, directly you can say that M1 is in saturation. Therefore, voltage at drain equal to voltage at gate. Therefore, M1 is in saturation. Once M1 is in saturation, I am going to regular equation for ID. Mu n COX by 2 into W by L into VGS minus VTH. Now, first I am taking VGS. See, VGS is nothing but a voltage at gate minus voltage at source. And at the same time, you are representing voltage at gate is nothing but a voltage at drain. So, which is a voltage at drain minus voltage at source. Voltage at drain is nothing but this is our drain current ID, which is VDD minus ID into RD. VD is VDD minus ID into RD. At the same time, this is the voltage at source. The same drain current is flowing through that. That is ID times 200 ohms. VS is ID times 200 ohms. Therefore, from this we can write VGS is VDD minus IDRD minus IDRS. Just to substitute the values in that. Which is VDD minus ID times RD plus RS. So VDD 1.8 volts minus ID into RD 1000, that means 1 kilo ohm plus it is 200 ohms. 1200 into ID. Just to substitute that value here. Therefore ID is mu n COX 100 into 10 power minus 6 divided by 2 into W by L 5 by 0.18 into VGS 1.8 minus 1200 ID minus VTH 0.5 whole square. Just simplify this. I am copying this equation. See this? Now I am simplifying this. Therefore ID is 100 into 10 power minus 6. It is a 10 power minus 4 by 2 into 0.18. 5 by 2 into 0.18. 0.5 divided by 0.18. What 13.88 into 1.8 minus it is 1.3 minus 1200 ID. So this is a 1000 divided by 13.8. 724.6. 724.6 ID equal to 1.3 whole square 1.69 plus that is 144 into 10 power 4 ID square minus 2 into 1.3 2.6 into 1200 3120 ID equal to 0. Now just simplify this. Now it is 144 zeros into ID square minus 3120 plus 724.6, that is 3844.6 ID so plus 1.69 equal to 0. Again it is a second order equation in terms of ID. Therefore ID is minus B, it is a 3.3844.6 plus or minus square root of B square 3844.6 whole square, that is a 14780.949.16 minus 4 AC. C is 1.69 by 2A. 2 into 144 into 10 power 4. Just get the value of ID, required value. Directly go to required ID. ID is the minimum value, so it is minus of. Therefore, ID is 3844.6 minus. See, it is a 4 into 144 into 1.69. It is 973.44 minus 14780,949.16 square root of it. 2246. .4 divided by 288 into 10 power 4. That is a 3844.6 minus 2246.4 divided by 288. So it is a 0.554555 approximately milliamps. That is the equation for ID. Okay. ID is completed. And the next part is what value of RD is necessary to reduce ID by a factor of 2. So ID is reducing by a factor of 2. Okay, approximately you can take it 556. So which is 556 microamperes. So reducing half of it. Second part. Now let ID is half of it, 556 micro by 2. That is 278 microamps. Let us take this is the ID value. With this ID value, what is the value of RD? That is what you need to calculate now. Okay. Now VGS is VDD minus ID into RD plus RS. This is our equation. Okay, now you need to take RD value is unknown because you need to calculate RD with this current of ID. So that is 1.8 minus ID 278 micro into RD plus RS 200. So it is 1.8 minus, it is a 278 means 0.278 into 200, 55.6 milli, that means 0.0556 volts minus 278 micro into RD. That is 1.8 minus 0.0556, that is 1.744 minus 278 micro 10 power minus 6 into RD. Okay, into RD. Now we need to use VGS minus VTH in that. Therefore VGS minus VTH is 1.744 minus 278 into 10 power minus 6 into RD minus 0.5, that is 1.244 minus 278 into 10 power minus 6 into RD. This is the value of VGS minus VTH. Now substitute those things in your equation of ID is mu n COX by 2 into W by L into VGS minus VTH whole square. Just substitute the values. So ID is 278 micro equal to mu n COX 100 micro by 2 into W by L. The given W by L 5 by 0.18, 5 by 0.18 into VGS minus VTH whole square, this one 1.244 minus 278 micro into RD whole square. Now just I am simplifying this micro gets cancelled, and just I am simplifying 278 2.18 divided by 5, it is 20 point divided by 100, it is 0.20 square, 0.200 square root of this, square root of 0.2006. So it is approximately 0.4473 is equal to 1.244 minus 278 micro into RD. By simplifying, just take this one this side, this one this side, simplify, you get RD is now 1.244 minus 0.4473 by 278 micro, 0.244 minus 0.4473 divided by 278, 2.86 kilo ohms. This is the approximate value of RD. Okay, so if you reduce the ID value half, then your RD became 2.86 kilo ohms. Okay, so these are the problems on this. Now it is calculate the small signal voltage gain of common source stage. Very good. Now we are moving to common source stage amplifier. Okay, so they are asking the voltage gain of that common source stage. Just a minute. Meanwhile, you try to solve that. Now I am going to calculating the voltage gain of this. Already we solved those things in our regular analysis. Okay, and its voltage gain is, for common source stage, its voltage gain is minus GM into RD. That is the voltage gain of that. Okay, and GM value is square root of 2ID into mu n COX into W by L. That is the equation for GM value. Okay, now just first calculate the value of GM. Square root of 2 into ID 2 milli, the given ID 2 milli, 2 into 10 power minus 3 into mu n COX 100 microamps per volt square, 100 micro 10 power minus 6 into W by L 10 by 0.18. Just simplify this. So this one and this one gets cancelled. From this 2 I am taking 1 2 outside, and from this 10 power minus 3 taking outside. Now square root of 0.18. 2.35 into 2, 4.7 approximately, 4.7 milliamps per volts. That is the transconductance value. Now therefore its voltage gain is minus Gm into Rd. So minus 4.7 milli 10 power minus 3 into Rd is 400 ohms. 0.4, 4.7 into 0.4. That is 1.88. So that is the gain of the amplifier, common source amplifier. Now you observe one thing. You observe one thing in this 1.88. It is a very small value. It is a very small value. Now here I am trying to increase the gain. I am trying to increase the gain. For that, we do little bit analysis on this. Voltage gain is going to be increasing, but once you are increasing Rd, then the voltage at drain is going to be decreasing. Voltage at drain, Vd is going to decrease. Once Vd is decreasing, there is a chance of coming your MOSFET out of saturation. So to work as an amplifier, it should be operating saturation region. Okay, that is the problem. That is the issue. But we need to increase this Rd, but we are unable to increase that. Now the solution to that one is just replace the load Rd what you have by a current source. Okay, so once replacing the Rd by a current source, then the small signal in resistance of the current source is infinite. Small signal resistance of the current source. Okay, that is the best method to increase the gain of this. Is it okay? And at the same time, in linear circuits, your gain is simply transconductance into output impedance. Transconductance into output impedance is the gain of that for a linear circuits. Okay, so the best method to increase the gain is to replace Rd with current source. To replace Rd with current source. Now we need to replace that by current source. Where is our current source? Okay, we can check that current source and we can replace that Rd by current source. And before going to that, we have another part in this, that is Verify that M1 operates in saturation. Now in this circuit you need to verify the M1 is operating in saturation or not. Okay, to verify that M1 is in saturation, for that VDS should be greater than or equal to VGS minus VTH. This is the condition we need to check. Okay, now we know the equation for VGS. So in saturation, VDS is greater than or equal to VGS minus VTH, and we have an equation for VGS, that is VTH plus square root of 2ID by mu n COX into W by L. Just to substitute the values in this. VTH is 0.5 plus square root of 2 into ID 2 milliamperes divided by mu n COX they given as 100 and W by L 10 by 0.18. So it is 0.4 they given. By it is 100 micro 10 power minus 6 into 10 by 0.18. This is 10 power minus 4, 10 milli gets cancelled. It is 4 into 0.18 square root of, so it is 0.4 plus 8.842. Is 1.24 approximately. 1.24. That is the VGS. Okay, and once you know the VGS, immediately go to VGS minus VTH. That is 1.24 minus 0.4. So it is 0.84 volts. That is the VGS minus VTH. Next we get the VDS. So VDS is applying KVL to output loop, we get it as a VDD minus IDRD. VDD 1.8 minus ID 2 milli into 400 ohms. That is 1.8 minus, it is 0.4, 0.8, that is 1 volt. So 1 volt is greater than 0.84 volts. Therefore VDS is greater than VGS minus VTH. So once it satisfies this equation, therefore MOSFET is M1 is in saturation. M1 is in saturation. Okay. Now at the same time, just before you mention the better way to increase the gain is to replace the load by current source. Now I am going to replacing that current source. So whatever the NMOS and PMOS we have, by using those two we can easily implement the current sources. Okay, we can easily implement the current sources. For example, first I am taking NMOS. So this is, let us take a point X, and this is the biasing voltage. Now this biasing voltage is going to operate this in a saturation. Now it can be replaced by a current source. current source. I1. That is the current source. And the same thing can be implemented by using PMOS also. So it is now it is replaced by VDD. It is as usual can be replaced by a current source. This is the current I1. Now this is the current I1. Okay, if required, you can replace your source by your load resistance by a current source. Then you can get the more gain, because it's a small signal resistance is infinity. Okay, see this. Now here, here they use the current source. The meaning of that one is, here it is nothing but this one. Now that one, this is connected to VDD, and this is the point Y, somewhere here Y. Now in place of this, if you are using this, that is also correct one. Both are representing the same. Okay, now what they want, assume M1 operates in saturation. Okay, it is in saturation, fine. Then determine the voltage gain of the circuit shown below is. So they want voltage gain. Voltage gain is actually, this is a common source amplifier. Voltage gain is minus GM into small signal output, small signal resistance of this one is R01. R01 into small signal resistance of this one is actually capital RD. Capital RD represents small signal output resistance of this current source. That is more or less infinite. Okay, now it can be written as, therefore AV is approximately minus GM into R01. Now R01 is, you observed or not, R01 is much greater than the whatever the drain resistance previously we are using RD. RD is 400 ohms, but R01 is of the order of 5 kilo ohms, 10 kilo ohms, like that. Okay, so this is the best way to increase the gain. Okay, just to there we replace whatever the MOSFET there we have, a drain RD we have, just we replace that RD by a small signal, by a current source. That is the modification we done on that. Now see this, below figure shows the common source stage using current source load. Yeah, see this, this is a PMOS, and here it is a biasing. It is acting as a current source. It is acting as a current source. Here it is biasing. It is acting as a current source. Can be replaced by a current source. Current source. Okay. Now what is the gain of this? So the gain of this one is minus GM2 into, this is the driver, because GM2 into R02 parallel with R01. Small signal resistance of this. At output you can assume a small signal resistance of this R01 in this direction. Okay, similarly its small signal resistance is R02. Now its gain is minus GM1 into, because this is the driver, into R01 parallel with R02. Okay, it exhibits some resistance, some output resistance, just I use that. See how simple it is. So once you know the basic concept, and once you have a proper idea on concept, you can easily solve the problems. Clear? Next one. See, next, determine the voltage gain of the following circuit shown below figure. See, now they want the voltage gain of this one, and two conditions they mention. One is lambda 0, that means by omitting channel length modulation. After that, lambda greater than 0, that means by considering channel length modulation. Okay, just you try yourself first this problem. You try yourself. Now, determine the voltage gain of the following circuits shown below figure. Okay, first case, first for better purpose, I am going to copy in the circuit. Yeah, first I am going to take in lambda equal to 0 with lambda 0. Lambda 0 means by omitting channel length modulation. Omitting channel length modulation in this sense, R naught is taken as approximately infinity. Okay, R naught is infinity. So this is here you have, this is the driver device. It is acting as a load, and in that, drain and source both are connected to supply. This is called, this type of connection is called diode connected device. We call it as diode connected device. M2 is called diode connected device. Diode connected device. Okay, and impedance looking into this direction became 1 by GM is 2, so it is GM2. Okay, that is the GM2. Okay, we go and calculate that. So this is the gate 2, gate, source, VGS, GM, VGS, it is the drain. I am not taking RD because that RD is infinity, and a drain, under IC analysis, this drain and gate both are connected to ground. DC supply connected to ground, so gate connected to ground, gate connected to ground, drain connected to ground. We need to calculate at source and we need to calculate the impedance. At this point, simply connect a dummy source, dummy voltage source, Vx Ix. You are saying this is Ix, current from this direction, but current from this direction is going to be, current from this direction is coming, it is GM VGS is coming. Therefore, Ix is equal to GM VGS. From that, Vx, and one more thing, this Vx is nothing but a minus VGS. Here Vx is nothing but a minus VGS. minus VGS. Therefore, now Ix is, it is minus GM VGS. Now minus GM into VGS is nothing but a minus Vx. That is GM Vx. From this, Vx by Ix is nothing but impedance looking into this direction, that is R, let us take, that is 1 by GM. So 1 by GM2. Now the circuit became so this is your circuit. It is grounded. So it is ground, and here is a load, a diode connected device, which is 1 by GM2. That's it. Here taking output. Now get the gain of this. Get the gain of this. It is again a common source. With a load in place of RD, we have 1 by GM2, and its voltage gain is minus GM into GM1 into load RD, because we are omitting the R01 of this, because that is infinity. The given R0 lambda is 0. 1 by GM2. 1 by GM2. Okay. Now that is minus GM1 by GM2. If you want, you can substitute the values of GM. Both are in series, so same drain current is flowing through both. Mu and COX, if you assume both are same, only W by L values are changing. So that is minus of square root of W by L of device 1 by W by L of device 2. W by L of device 2. So that is the way to answer the problem. Okay. That is the way to answer the problem. Next one. Next one. See, next one is I am considering the same one with lambda not equal to 0. Okay, with lambda 0, we replace this one by 1 by GM2. 1 by GM2. Now once we are neglecting with lambda not equal to 0, just connect a, that means R0 is present. In that case, the equivalent circuit is like this. So this is the circuit, and here 1 by GM2 I am connecting as a load. At the same time, you need to connect R02 parallel to that. R02 parallel to that. In this, and in another one, the same way, here is R01 connected. Output impedance of this R01. Now totally its gain became minus GM of GM1 of output impedance of small signal drain resistance of this one is R01 parallel with 1 by GM2 parallel with R0. Very simple. So once you know the basic information, from that you can do the remaining things. See, once it is a diode connected device, it can be replaced by its 1 by GM2, and lambda not equal to 0. Because of lambda not equal to 0, I connected a output small signal drain resistance of that also, that is R02. Okay. Okay, so this is the way of solving the problems. Next one. So this compute the voltage gain of the circuit shown in below figure if lambda equal to 0. See this? Here also gate and drain both are connected to same potential. Gate and drain both are connected to same potential. Once both gate and drain are both are connected to same potential, that is going to be a diode connected device. So it is a diode connected device. Once it is diode connected device, you can replace it by its 1 by GM2, simple GM2. Now your circuit became so this is going to be your circuit. 1 by 1 by GM2. So now it seems to be a common source amplifier with degenerative resistor. Therefore it is common source amplifier with the degenerative resistor. With the degenerative resistor. Okay, with a degenerative resistor. Now here degenerative resistor is 1 by GM2. It is acting as a degenerative resistor. Now I am going to copying this circuit. For this circuit we need to calculate the gain. For this we need to calculate the gain. So it is output voltage. We need to calculate the gain of this. Okay, so to calculate the gain of this, just to replace this circuit by its or from the knowledge of degenerative, we can write it as minus RD by 1 by GM1 of this one plus 1 by GM2 of this one. Okay, now or we can do that small signal equivalent. In small signal equivalent it is connected to ground. Now replace this one by its small signal equivalent. So gate source GM VGS, it is VGS source gate. Here you are applying input voltage. It is the drain. At the drain end it is RD connected to ground. Source, at source we have 1 by GM2 connected to ground, and this is a GM1. Okay, GM1, and taking output here, this is our input voltage, and the same current is flowing through this minus GM1 into VGS. Okay, so output voltage is from this minus GM1 into VGS current into RD, that is the output voltage, and input voltage is VGS plus voltage across this. Voltage across this is the current flowing into this. This is the current flowing into this. GM1 VGS. Therefore, input voltage is VGS plus GM1 into VGS into 1 by GM2. Okay, now just get the gain. Now gain is output voltage by input voltage. Output voltage is minus GM1 into RD into VGS divided by V input is, take the VGS common, 1 plus GM1 into 1 by GM2. This gets VGS gets cancelled. Take this GM1 here, this side. Therefore, voltage gain is minus RD by, take this GM1 this side, 1 by GM1. So now voltage gain is minus, this is the equation you get, minus GM1 into RD by 1 plus GM1 by GM2. By dividing that with the GM1 both sides, numerator and denominator, minus RD by 1 by GM1 plus 1 by GM2. Okay, that is the equation for voltage gain. So in this problem, what they ask, compute the voltage gain of the circuit shown in below figure if lambda equal to 0. That's it. Okay, so this is the way to calculate the problems. Next problem. Now see, this is the problem. You try to solve this. Compute the output resistance of the circuit shown in below figure. Okay, now so in this circuit, I want to calculate its output impedance. To calculate its output impedance, see this, for this source in this circuit, gate and drain are at same position, same potential. Both are shorted because now you check this, gate and drain both are shorted. Both are shorted. Once both are shorted, it is nothing but a diode connected device. So it can be replaced by, it is also a diode connected device. It is also a diode connected device. See, so once it is a diode connected device, it can be, see, they did not mention any complications on lambda value, any conditions on lambda. It is a diode connected device. So it is a diode connected device. So it can be replaced by 1 by GM2. If lambda equal to 0, if lambda not equal to 0, you can replace it by 1 by GM2 and at the same time R02 also, you can replace this one by this. Okay, now the circuit can be written as simply now. So whatever the diode connected device there we have, I'm going to replacing that by like this. That is 1 by GM2 parallel with R02. If lambda 0, you can take R02 in infinity, no problem. Now we need to calculate the output impedance of this one. Okay. So for this, I'm going to replacing this one by its small signal equivalent. At the same time, connecting a dummy source here. Now, first, it is a biasing voltage. For biasing voltage, it is connected to ground. Okay, connecting that one to just a minute. Yeah, it is biasing. Biasing connected to ground. It is a gate. Device 1 it is. Source it is. Source 1. It is GM1 VGS. This is R01. It is a drain. It is a drain. Here I am connecting a dummy source. Current Ix. It is Vx. Ix Vx. Now at source we have a resistor. That is 1 by GM2 parallel with R02. And this is the VGS. And here gate connected to ground. Gate connected to ground. Once gate connected to ground, it is connected to ground. Now the voltage across this became VGS. Voltage across that one is VGS. This is the GM1 VGS and this is Ix. Now the current through this one is Ix minus GM1 into VGS. Now just apply KVL to this output loop. Or KVL to this output loop. Okay, apply just KVL. By applying KVL, what you get is Vx equal to Ix minus GM1 into VGS into R01 plus the same Ix current is flowing through this. Ix into 1 by GM2 parallel with R02. 1 by GM2 parallel with R02. Now just substitute the value of that VGS value. VGS is nothing but Ix parallel with this. That is minus Ix into. From this we can write VGS is minus Ix into 1 by GM2 parallel with R0. Just use this one here. Therefore, it is Ix into R01 minus GM1 into R01 into VGS is minus of this. It became plus IX into 1 by GM2 parallel with R02 plus IX into 1 by GM2 parallel with R0. This is our Vx value. Now I'm copying this for simplification purpose. So that is the Vx value. Now get the Vx by Ix. It's very easy to you. So this is the equation. Now from this Vx equal to, so here is Ix, here is Ix, here also Ix. Directly I am taking that Ix this side, equal to R01 plus, or just take R01 common from this. Okay, R01 into 1 plus GM1 into 1 by GM2 parallel with R02 plus 1 by GM2 parallel with R0. That's it. Or simply you can write it as R01 plus R01 plus 1 plus GM1 into R01 into 1 by GM2 parallel with R0. This is the another way of representation. Okay, so this is the way of calculating output resistance of a given circuit. Okay, and after that you go for some little bit modifications. So because 1 by GM2 is less than R02, so you can replace this by approximately GM2. Okay, so they are the simple things. Now next, compute the output resistance of the circuit shown in below figure. See, this is also similar to the previous model. See, under calculation of output resistance, you get the impedance of this. This is going to be, no doubt at all, this is simply R02. That is simply R02. Once that is R02, now this is going to be equal to, it can be now written as, the circuit is see this. Now the output impedance of this one is R02. Now you can replace it by R02. R02. In previous case, in place of R02, we have 1 by GM2 parallel with R02. Why? Because their drain and gate and drain both are shorted. That is the diode connected device. Okay, now we can write directly value of this. Now I am writing directly output impedance from the knowledge of previous problem. From the knowledge of previous problem, we can write output impedance is directly R01 plus taking R01 common into 1 plus GM1 into this one R02 plus R0. That's it. Okay. Or you can write this one as R01 plus R01 plus R02 into 1 plus GM1 into R02, R01. This is the another way of representation. Okay. But compared to 1, this is much greater than, and compared to the multiplication of this, compared to this, multiplication is much greater. Now, so it can be written as R01 plus R02 into 1 plus GM1 into R01. This is our issue or problem. Now R01 plus R02 into 1 into GM1 into R01. Next level simplification. After that, this is greater compared to this. Now it is a GM1 into R01 into R02. That's it. This is the approximate output impedance. Okay. So that is the way to solve the problems. Okay. And we have few more problems. So next session we go and solve the remaining problems. Next session we solve the problems. Another session. Here are the few of the top educators from an academy. Tiwari Sir, IIT topper, having 7 years of GATE and ESE teaching experience, and he is the author of the book GATE in 75 days. He teaches the mechanical engineering. Ankit Goyal Sir, he obtained All India first rank twice in GATE Electrical, and he was awarded President of India Gold Medal in IIT Indore. He teaches electrical and electronics engineering. Sanchit Jain Sir, he is a computer science faculty, having a teaching experience of more than 8 years. Jaspal Singh Sir, he is ex-IAS officer. He got All India 4th rank in that IAS. He is a scientist, GATE, State Service Exams, PS and PSU topper. Ex-senior made easy faculty, having experience of more than 12 years. And here are the few more top educators from an academy. Now, these are the different disciplines available in an academy for GATE and engineering service: electronics and communication engineering, chemical engineering, mechanical engineering, computer science and IT departments, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. Mathematics is common for all, and general aptitude also common. So as we mentioned, there are two plans, plus plan and iconic plan. In this both, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, live tests and quizzes. The same thing you get here also. Same thing you are getting here also. Okay. And but in iconic plan, once you written the test or you attempted a quiz, it was forwarded to your personal coach. Your personal coach do the personalized test analysis on that, and based on your performance and that, they prepare a study planner to you. And at the same time they provide respective study material also to you. By following these two, every student gets success in their examinations. Okay, every student can get success in their examinations. Now in plus plan there are different subscriptions: 1 month subscription, 3 month subscription, 6 month subscription, 12 month subscription, 18 month subscription. That means 1.5 year subscription and 2 year subscription. And the beauty here is EMI option also available. As a faculty, I recommend the students to take minimum 1 year subscription. So that minimum 1 year is required for a student to complete the preparation for all subjects in all aspects, and to write the more number of examinations, identify the gaps in their preparation, and to fulfill those things they need minimum 1 year. And don't forget to use my code VROUT10 during subscription. By using my code VRAW10 during subscription, you get it by 10% discount. You get it by 10% discount. Okay. And next we move to Iconic plan. In Iconic plan, 2 subscriptions are there, 1 year subscription and 2 year subscription. And for 1 year subscription, it is 50,250 rupees. By using my code VRAW10 during subscription, you get it by 10% discount. 10% discount. 45,225 rupees. Okay. And here also EMI option is available. Don't forget that. Okay. Now, see, don't forget to use my code VRAW10 during subscription. Hit the bell icon for getting notifications. Subscribers, don't forget. And please give your valuable comments on YouTube and select the hand symbol and join our Telegram group for getting latest updates on our upcoming videos. Okay, to get that, join our Telegram group. Okay, so once again I am thanking one and all for spending your valuable time with us, and once again I am welcoming you all to this beautiful online learning platform, an academy. So my dear students, during this pandemic, outside it is a situation is not good. Okay, so please restrict your movement at outside, stay home, stay safe, but continue your learning with an academy. Thank you very much. Thanks for spending your valuable time with us.